So that's something else to look up on online as well.
Yeah, thanks for that. I mean, we do have workforce development efforts that go on, small business outreach is only so much.
Old projector, and it says auto adjust. You have to hit the button for it to adjust. All right, so thank you, George. I'm going to bring up our next keynote speaker, Keith Davies. So George talked a little bit about what's happening future-wise, what the government is doing to invest in supporting growth in some of the technologies that we talked about here. Many of the technologies that we're involved with at INS and what we're implementing, hopefully in many of your organizations. And Keith then we'll kind of take that down to the next level and talk about actually, I think, an actual real organization in that GE using kind of eating its own dog food, so to speak. And a lot of the developments that they're doing with the software to benefit their own manufacturing process, but also benefit all of you as that kind of trickles down into the development of a lot of the software that's going on here. So I'm happy to introduce Keith Davies. He's the General Manager of Prophecy Core portion for intelligent platforms. In this capacity, Keith is responsible for providing product development direction to oversee the underlying software platform across all of the Prophecy applications. And he's also responsible for uniting the portfolio together, so bringing all those solutions together under a common set of capabilities. Keith has a great background here, and you can read it in the biographies. He's got a lot of manufacturing technology experience, and we're happy to have him here. And please welcome Keith Davies.
Thank you. So first, welcome to Devcon, and congratulations on INS on 25 years. Quite an accomplishment. I'm going to talk through the industrial internet and how that relates to manufacturing and the initiative that we call Running Factory. And so to really start that, I have a video which is going to talk about some of the work that we're doing in one of our facilities in Greenville, South Carolina. And this facility really, when we think about how do we make the industrial internet real in a manufacturing context, this will provide a little bit of background in terms of what we're doing, and then I'll go through and describe this in a little bit more detail.
The relationship between humans and machines is exciting, yet increasingly complicated. In the 19th century, machines connected us. Now we are constantly connected to them. As we become ever more entwined with our technology, what's stopping our relationship with machines turning into a chaotic, tangled mess? The answer? The industrial internet. It's a massive revolution in technology, but what is the industrial internet? It all starts with a tiny sensor, or often several thousand of them, attached to a big machine like an airplane or a turbine, creating a new class of equipment called brilliant machines. The sensors capture real-time data about all of the machine's different parts. As quickly as it's gathered, the data are wirelessly streamed to the cloud. There, it's sorted and analyzed by powerful software. If the software notices something is wrong, like a part is about to break, then it tells a person, yes, an actual person, who can then order a replacement part and schedule when to fix it. The best bit is we know something's wrong before it's broken, rather than having, say, your whole power plant stop working unexpectedly. use interactive technology to increase fuel efficiency and productivity. An aeroplane in flight can tell the engineers on the ground what will need to be repaired before it's even landed. Scans from an emergency patient can get immediately delivered to specialists to help save lives. GE predicts that the industrial internet could not only add $500 billion to the energy sector alone, but could also raise income by 25% and provide people with more consistent, reliable sources of energy and transportation. Now that's a technological revolution we can all be excited about. Thanks for watching. Don't forget to like this video if you enjoyed it, click subscribe, or click on the next video to watch more.
Okay, so that's a little bit about what we think about as far as the industrial internet. And if you think about why is this important? Why does it matter? Why are we spending time focusing on that? Well, apart from being good global citizens of the world in terms of being able to optimize plants to reduce energy consumption and be able to produce goods faster, there's a lot of money in it. There's a lot of money in being able to save 1% in terms of energy consumption, to be able to build a product just 1% faster, to be able to increase productivity and efficiency by 1%. So this is why it's a big deal to us in terms of GE. We are not only a software company, we're the 14th largest software company in the world, but we're also a manufacturing company. So we're building a number of different components. So it's real money to us, but also to our customers. You know, one of the things that I think when we think about this problem is really inherent to our DNA. It's really inherent to the way that we think about the company. And if you think about Thomas Edison, and you think about how GE was first founded, I think this quote where I found out what the world needs and then I go about the process to invent it really holds true for Thomas Edison and the light bulb, but also holds true when we think about the industrial internet, when we think about Brilliant Factory. How do we go about inventing a smarter way to build products? And really, that's what the industrial internet and Brilliant Factory are all about. And so going back to the presentation, the video that I just showed, there are really three components of Brilliant Factory, and I'll talk about each of these in a little bit more detail as I go through the presentation. But one is a cloud platform. And so the video talks about sensors on machines being able to communicate information to the cloud. And so we have a cloud platform for the industrial internet. It's called Predix, and George alluded to it a little bit earlier. But this is a platform not only for GE, but for other companies as well to build capabilities, to build applications on top of that can be leveraged for customers. Second, world-class data and analytics. So in terms of data, when we think about the cloud, there has to be a capability to be able to store that information. So George mentioned that there's a lot of information in a manufacturing sense coming from these devices. Well, we need to be able to store it somewhere to be able to use it. And so we've created a world-class storing capability for on-premise devices. We're in the process of creating that in a cloud environment, which gets into big data. When you start to have that data, having it is the keys to the kingdom, but you have to do something with it. And so those analytics that allow us to be able to predict equipment downtime, failure of assets, to be able to compare one site versus another are extremely important. And then the third one is manufacturing productivity tools. And so when we think about, there was a question earlier where there are many sites that are still using spreadsheets. And so how do you get started? And so these manufacturing productivity tools, things like OEE and downtime reporting and SPC, these help you go from spreadsheets and a very one-off way of operating a plant to having a consistent way of looking at your operations and being able to make them more efficient. And so these are not three disparate initiatives, but this is, when we think about Brilliant Factory, these are the components that really bring it all together. And so next, let me talk a little bit more detail about these manufacturing productivity tools. And first, let me refer a little bit of an analogy that I think resonates to me. I'm an athlete, I play soccer. And so the Fitbit analogy, where there's a piece of equipment that you can put on your body that's going to monitor how many steps you're taking. It's going to monitor your sleep patterns. It's going to monitor your heart rate. And so Connect is just putting this piece of equipment on, and you're getting all of this information that you previously didn't have before. And so it's then up to you to determine what do you want to do with it. You could choose to do nothing with it, or you could choose to say, well, I felt really good when I ran yesterday. How did that relate back to my sleep patterns? How did that relate back to what I ate? And so you're getting insights that you can choose to look at, and you can see these insights on your phone, on the web, and you can then use those insights to be able to optimize your performance. You can say, well, here's what's going to allow me to have a better heart rate, here's what's going to allow me to run faster, and so you can use it to improve the way that you work out. So we think about manufacturing in much the same way. When we think about connectivity, and so as was mentioned earlier, where a lot of companies are still using spreadsheets. So the first thing is just to start getting information off the devices. And I'll talk a little bit more about what are we doing in terms of connectivity to start this process. The first thing is, just like with the Fitbit, is to connect. So that's the sensor-enabled manufacturing equipment. Once you've done that, you can start to get information. You can start to understand when is that piece of machinery running. You can start to understand your quality metrics, OEE, and that allows you to gain insights into your operations, where you can then, for that specific plant, you can see how it's running. And then when you move to optimize, you can start to collect that information across your set of plants, and you can determine what are the sets of best practices that I should be employing across my fleet in order to drive improved efficiency, in order to drive increased productivity. And so we think about it in terms of get connected, get insights, and get optimized. Those are really the plays that we're running across manufacturing, and we're using these to drive a set of outcomes. And so if we just focus right now on get connected, there's really a couple different ways, a couple different lenses that we're really looking at this through. And so the first one is who. So who is this really focused on, get connected? It's really focused on the operator. And it's really providing the ability to monitor devices, to be able to look at machines and material that are coming in into the line. And this is allowing you to really think about how can you improve your uptime. It's taking a look at getting a view of the tools, the labor that's being used, and thinking about, given the information coming from your ERP system, how can you align that in terms of your labor force to schedule it accordingly. And so this is, when we think about how do we transition the get connected, get insights, get optimized, how do we really move that from being a set of capabilities to something that's really going to drive productivity and drive efficiency. And so in terms of connectivity, we're really talking here at the sensor level. We're talking about the ability to connect to machines, be able to process this data. And this is really starting the process of how do you optimize your operations. You have to first be able to get the data. And so when we think about Get Connected, we think about how do we implement this internally within our plants, how do we implement this for our customers. One of the key things that we focus on is time. Being able to get machines connected quickly so that we can start this process of being able to look at the data, being able to mine new insights into the operation. And so there's a process here that we work through with internal and external customers to work through this Get Connected play. And the first one is really meeting with the customer, cataloging the equipment, understanding the various types of equipment and the readiness of that information to be able to pull information off of it. Second We then dispatch our teams on site to be able to work with that piece of machinery and to be able to pull information off. 3, we have what's called a field agent. So this is a piece of hardware that sits in a plant environment, has a historian embedded within it to capture that data. And so the data that's coming in off this device is being collected. This goes back to what I talked about before, where data is really the keys to the kingdom. So you need to make sure that you have a very powerful historian to be able to capture that information, all the information that George alluded to earlier. And so that field agent, that historian is embedded within the field agent. The field agent creates a secure connection to the cloud. And so we think about how all this information and all of the data about your operations. As George mentioned, cybersecurity is a very big deal these days. And so we need to make sure that this information isn't available to anyone, but it's very, very secure as it's being transported to the cloud. So that field agent, steps 3 and 4, the field agent takes care of that secure connection, that secure handover with the cloud. Once there, so it's connected out. The world this is in you are the customers that we work with. And this is good, showing kind of a shot of this is the HMI graphic. And you can see it's very comprehensive. There's a lot occurring here. However, when we think about what do we want to transition to, we want to transition to an environment where different users have access to different information depending upon what their jobs are. We want to give you the ability to view the HMI graphic along with what alarms are being generated from it, but do so in a way where you can break down that graphic into different parts of the plant. So you can focus on what's connected, you can focus on a specific area if there's a given problem or a given set of alarms that you want to drill into. Of course, this has different trending information as well. So the idea here is we're giving the operator a user interface that allows them to be more efficient in being able to visualize the information and take action accordingly. Next, let me move into the unified manufacturing operations, which is under Get Insights. And so again, this is for a plant manager. And so this is thinking about, given all of these connected pieces of equipment in my plant, how do I actually make use of that information? And so this is looking at working process, labor utilization. This is looking at project schedules. So what I mentioned earlier, where we have pieces of material coming into the plant environment. We want to be able to schedule that accordingly, both with machines and with labor, in order to minimize work in process. That's what the plant manager is interested in, but you have to have access to the data to do that. And so if we go back to our solution map, then what we're looking at in terms of Get Insights is really the other 3 boxes here. So this allows us then to be able to think about material, visibility to material, visibility to labor, visibility into genealogy information, so that you have a very good awareness to how the product that's being produced is coming together. Information on downtime. So when is a given piece of manufacturing equipment running, and how does this relate to work in progress? How does this relate to material and equipment efficiency as well? So with that information, these are the building blocks to be able to really think about how do I optimize my operations. And so when we think about, in terms of some of the things that our plants are thinking about when they're looking at making their operations more efficient, it's really thinking about VCP, variable costs, and being able to minimize those variable costs. And so for the different components components that we think about to be able to get to that point: machine intelligence, labor intelligence, material intelligence, product intelligence, all coming together. And it's based on that data that we're being able to pull together from across that manufacturing plant in order to obtain these insights. And so when we think about the job of the plant manager, when we think about, very similar to the operator before, how do we allow that person to be able to take action on information? And so today, that's difficult. It's a difficult process because there's many different tools just in prophecy that are used. And so there's a variety of different applications that you would go to. Each of them have a different data model. Each of them have a different user interface. I'll talk to this problem a little bit later when we talk about, in general, how are we solving the user experience problem associated with Brilliant Factory. But this is the world today. The world tomorrow gets us to the point where, again, similar for the operator, the manager also has a dashboard that he can go to, which has some of the same components and some different components. But it's customizable to that specific user or the information that they're looking for. It's consistent. There's a consistent way of taking that information that's coming in across the plant and consolidating that into a common data model format so that we can relate this disparate information, show it to the user, and use that, again, to drive decision making. And so the third component of this is get optimized. And this is thinking about at a step above the plant level, when you start to think about all of your plants coming together, how do you start to drive best practices across the enterprise? And so this is looking at taking best practices from one plant and applying them to others. It's thinking about, how do I keep my manufacturing equipment running so that I have no unplanned downtime. And so this includes the other 4 boxes there. And so part of this is what I mentioned, where we think about, how do we monitor these assets? Now that we're pulling data from these assets, how do we use that to predict failure so that we can inform our customers of this ahead of time and prevent a failure in the plant and a loss of productivity. And so there's a platform that we're using to be able to provide these analytics, which I'll talk to a little bit later. It's also thinking about fleet level analytics around downtime and around equipment efficiency. And of course, there's a user interface, another dashboard that's tailorable and configurable to this user, that's going to provide that fleet level information to allow them to make decisions. And so when I talked earlier that we have a cloud-based platform for being able to do this, this is something where we've really created the first industrial platform, the first cloud-based industrial platform for the industrial internet. And it is called Predix. And when we think about it, there's a couple different pillars that allow us to be able to create this platform. And so one is, of course, it's industrial. So we're not trying to create a platform that's going to be used by consumers. Two, it's something where when we talk about building capabilities that sit in the cloud, whether that's a data repository for being able to take all the information that's coming from at a plant level, or whether it's analytics that we're running, we want the ability to deploy this quickly to the cloud. So that's what DevOps means. And then third, it's a platform as a service. So we're offering capabilities that sit in the cloud that can be consumed. And so when we think about this, again, it's uniquely industrial. This is something where these 4 pillars, where we have securely connected assets, so the idea that security matters, that cybersecurity is very important. We have to make sure that we are able to pull the information from the devices into the cloud securely. It's industrial big data. As George mentioned, there's a lot of data. We need to think about, how do we store that? How do we make that available? Data science, this is the idea of being able to think about, how do we make sense of all this information? And 4 is that cloud platform itself, and being able to offer capabilities to end consumers. So if we dive into the architecture of this, this is at the plant level. where we have the machines. These are, there's a line where this connectivity to the plant is really provided through that box that I mentioned called the field agent, where we're able to provide that secure connectivity. Data, in terms of data, this is the data repository that we're creating in the cloud. It's providing horizontal scalability. It's providing an environment where because we're creating this in terms of small components called microservices, we have the ability to look at what components are taking a long time, and we can scale those independently. We can put them on a separate VM and launch those. So this gets to the point where it becomes very fast to be able to leverage this data. Security is a component, and the analytics that I mentioned before are important. And so when we set out to build this platform, we didn't set out to build all of it ourselves. We're leveraging, if you look at the level below that Cloud Foundry, that is a platform that is created by a company called Pivotal. We've made an equity investment in Pivotal. We are not the only ones that think about this world. SAP, for example, with HANA, has gone the exact same path where they've taken HANA, they're creating microservices with it, and those are exposed in exactly the same way that our capabilities are exposed today. And so many of our manufacturing plants leverage SAP, and we can then use this platform to be able to tie those capabilities together in the cloud. If we think about the step below that, we add the infrastructure. So I'll talk a little bit about cybersecurity in that subsequent slide, but we don't just think about cybersecurity at the level of connectivity from machine to the cloud. We think about it all the way down to the physical level. And so companies like Amazon are creating AWS, Amazon Web Services, to be able to provide cloud capabilities to customers. That's using their own hardware. We look at that and we say, there's nothing we can do to be able to secure that hardware level. And so we are creating our own data centers. We're buying our own hardware for this Predix platform so that when we think about security, we think about it at the hardware level all the way up through and including the software layer. So it's a very different platform than what anybody else in the industry has today, and we believe this allows us to provide a lot of differentiation in the marketplace and allow our customers to take advantage of new capabilities much faster. And so I mentioned cybersecurity and how we're working at the hardware level. And so I also mentioned the fact that this platform isn't just for GE, but we're allowing other vendors to be able to create capabilities into it as well. So if you think about Apple, you think about an app store. So all of us can create applications that sit in the App Store. The way that Apple makes sure that those applications are not a threat to cybersecurity is they go through an audit where they will look at the code and they will run assessments to make sure that it's secure. We do exactly the same process internally within our own applications as well as externally, so that we go through that certification process with the software to make sure that there are no cybersecurity threats. We have our own team called a red team that are certified hackers that will try to hack into our code, try to create security vulnerabilities. And so we believe through this process that we actually have a more secure environment than would be possible if you were just running it on site, leveraging hardware from any vendor, and not going through a lot of these certifications and checks. I mentioned microservices earlier, and so the idea here is that when you start to build components, the idea of this model on the left-hand side, think about an application that does many different things. If you decompose that, break it down into inputs, outputs, business logic, then what you can start to do is leverage that for other applications. And that's in a very general sense the idea of what we're doing in this platform. It also allows us, what I said before, you can start to scale these components individually. So if you have a number of users that are all leveraging a specific capability, you can spin up an extra VM or 10 VMs or 100 VMs to be able to handle that load. And that's the idea of horizontal scaling that the cloud provides. Next, I'm going to talk a little bit about world-class data and analytics. And so, many of you are familiar with our Prophecy Historian product. We made a lot of advancements in Historian to be able to compete with companies like OSI Pi. And that's in terms of read performance, write performance, but we're also adding in a number of capabilities to mirror data to be able to provide administration across the historian capabilities. So when you think about your historian capabilities sitting in a number of plants, you want the ability to administer that in one place. And so we're adding in a lot of those capabilities to handle not only at a local level, but an enterprise level as well. The analytics that we provide are through a product called Smart Signal. And this is a product that monitors machines and looks at a number of different parameters like vibration and temperature and pressure, and uses those parameters in conjunction with each other to be able to predict failure. And so you don't just look at temperature, you don't just look at pressure, but the idea of being able to aggregate these variables together and look at when is this piece of machinery running in a steady state. There's a certain threshold that these parameters can operate in. Because we're connected to these devices and we're pulling this different information from it, we can use this information, use this tool to be able to look at the data we've collected and predict failure. And so this is something where this is not something that's in development. We're monitoring over $37 billion worth of assets using this product today. So it's very real. Our success rate is over 99% if we look at where we were last year in terms of catching failure. So it's very, very certified and true product. We're taking these capabilities and decomposing them into microservices and putting it in a cloud environment so that it operates that way as well. And so when you think about this tool, what it does is it captures these failures early. So this isn't something where if you run alarming, alarms will typically tell you the problem after it's happened, after it's tripped that alarm, after it's crossed a certain threshold. What this tool is doing is it's giving you early warning. It's an early warning detection system. And so you have the ability to be able to go in and then determine, you give yourself a bit of time to be able to prevent that failure from occurring. And so next, let me talk a little bit briefly about where we're going in terms of our roadmap around data and analytics. And so when we think about historian, I talked before about being able to improve some of the capabilities around administration and doing the monitoring of data, not only at a local level, but at a site level. Improving the read-write performance is something we're focused on. And then as we get out to the right there, being able to think about in a cloud environment, being able to think about multi-tenancy, being able to think about elastic compute. And if you think about the industry right now, many companies are thinking about data, and they have open source data technologies. When we get out to the right here, we'll use capabilities like Cassandra and Kairos DB. These are open source databases. And so this is the idea where by being in the cloud, by being an open source capability, we can swap out technology as new technologies are available in the marketplace. We are not embedded with any different database technology. We can keep the APIs consistent so that how our applications and customer applications are leveraging that historian data doesn't change because the API is consistent. But we can then, through open source technology, we can leverage the latest advancements in the industry. Similar with Smart Signal, where we are today is that we have an industry-leading product that monitors equipment. We think about where we're going. We're providing more information to customers to be able to understand the problem and to be able to, once they get a report, understand the data associated with that so that they can pinpoint the problem and correct it as quickly as possible. When we get further out, that's where we're looking at being able to think about what we call knowledge management, which is where we say, here's a problem that we've diagnosed. We can then look in our knowledge repository and say, well, we've seen this problem 1,000 times in the past. 900 times this is the cause. This is where you need to go and fix it. so that we can leverage all of the experience, all of those $1 billion worth of assets that we're monitoring. We can collectively monitor this information and again, provide more information to our customers on how to resolve the problem. And so I mentioned already that the storing capabilities, we're putting them in the data column there, the data component of our cloud-based platform, so that it's available in a cloud environment. The same thing with Smart Signal. We're taking these Smart Signal capabilities that are running today in monitoring assets. We're putting them in our cloud in the analytics bucket so that they can be consumed not only by our applications, but by any of those applications that customers are writing that sit on top of our Predix platform. And so finally, it's great to have all these capabilities, but if you can't do it in a way that really simplifies the user experience, then it really doesn't allow the value, it doesn't allow our customers, our own plans as well as our customers' plans to be able to get there with the productivity gain as soon as possible. So when we think about the brilliant factory architecture, we're moving away from products where we have a number of disparate products that, as I mentioned in the earlier slide, have different user interfaces, have a different data model. We realize that's not going to get us to the point we need to get to. And so instead, what we're going to is a set of capabilities. So if you think about our portfolio today, we have a number of alarm management capabilities across our portfolio. We have a number of trending capabilities across many different products. We have user interfaces across every product. We have different data models across most of them. And so when we think about how do we actually put in place the user experience to be able to deliver this, that has to fundamentally change. And so this is an initiative that we have ongoing today where we're taking these capabilities and we're bringing them together. So there's one trending component, there's one alarm management component, there's one data model for representing data that we can then provide to the user interface. And so when we think about providing that data to the user interface, we can do it through a laptop, we can do it through a handheld, we can do it through an iPad. We can provide that user experience, and we provide the information to the user when they need it. And so when I mentioned earlier where there's a user interface for a plant manager, for an operator, for an executive, we have, in order to get to that point, you have to think about who are the different personas using the system, who are the users, what do they care about? And so we've launched into that aspect. But we don't just think about the user experience at the standpoint in time where you're actually using the system. We think about it from the very beginning. And so if we get to we have a set of capabilities, we can then move that into the purchasing process, where we can say, here are a list of capabilities. Do you want to do alarm management? Do you want to do historization of data? Do you want to run analytics? Do you want to view dashboards of information? We can bring that together, and a user can check off the capabilities they're interested in. From there, there's a single way of installing that information. There's not 5 or 6 or 10 installs. There's one install, which installs all the components that you're using. There's a way of being able to connect to the actual data, bring that into the system, and create the user interface for each of these personas. So I showed a different interface for an operator, for a manager, for an executive. Those can be created by an integrator or by systems administrator when they're building out the environment so that they can specify exactly what those users need. And then we can deploy that, we can connect to the data sources, bring the information in, and finally, we can execute it. We can take that information and we can display it across a variety of different environments, whether it's an iPhone, tablet, PC, whatever that form factor is, we can provide the information that's necessary to drive decisions quickly to the right user. And so, but it doesn't actually stop there, because the last step in the process is being able to upgrade. And so we realize that the information is never all going to be in the cloud. There's a lot of functionality that's going to be happening on site. There's a lot of analytics that are going to run on site. There's data that will live on site. You can't run your operations in the cloud. If you lose connectivity, your plant goes down. And so there will be a component where there are capabilities on the site. How do we in order for, how do we really improve the efficiency in an on-site environment during deployment? The way that we do that is to get to the point where we can push capabilities to one site out to the rest of the plants. And so going back to what I mentioned around the user experience, it needs to be a web-based UI so that there's one web-based UI rather than installing a rich client on a number of different desktops. In the cloud, it's very easy for us to provide new capabilities that can be consumed by users. We can version that, and it provides a very fast way of upgrading from where we are today to a new set of capabilities. So with that, let me walk through a couple slides and kind of tie this together. And so for us, I've talked about a lot of different capabilities. I've talked about a cloud platform. I've talked about going from a set of disparate products to a set of capabilities. I've talked about world-class data and analytics. And so that's a lot. And so you can easily sit back and say, how the heck are you going to pull this off? Well, we're investing $1.5 billion to be able to pull this off. We've got a site in the Bay Area where we have 1,200 people. We went from 0 to 1,200 in 3 years. And that team are building this cloud platform. And so this isn't the day of intelligent platforms going back to the timeline we looked at before. This isn't intelligent platforms trying to solve this problem. This is big GE trying to solve this problem and being able to deploy resources from across GE to bring these capabilities together. And so importantly, a lot of what we're talking about here already exists. We're deploying these capabilities to our own manufacturing plants. We're realizing the value in our own plants today. And so when we think about the first industrial cloud platform, we have that. We're inviting a select group of customers and partners next month to be able to take a look at the platform. So it's available now. Will be rolled out later this year. World-class data and analytics. I mentioned our smart signal products monitoring billions of dollars of assets today. Manufacturing hardware productivity tools. We're taking these, rolling it out to plants like the plant in Greenville that I showed in the video, and bringing this together in a way that it's a user experience for users where there's a way to be able to get to the information you need, get to it quickly, and make decisions. So the Brilliant Factory is here, and we're rolling it out in GE, and we'll be rolling it out to our customers more broadly. Thanks. Any questions?
I was just having multiple HMI softwares, but will your software for the cloud allow underwear apps to communicate with it as well?
So it would depend on how, if they could create capabilities in the cloud, just as SAP has done with HANA. If they went and did that, then a user would be able to take our microservices, take our capabilities, bring that with capabilities that they provide, and effectively create applications that way. And so when we view this platform, that's why we view it as an ecosystem, and how we view it as kind of working together with companies like SAP to really provide that end-to-end solution of being able to microservice enable the capabilities needed to run an operation. So it would depend on them, but in theory, they could.
Does GE publish any guidance on what type of bandwidth that a typical manufacturer would need to connect up to these cloud services? I mean, we're lucky in some of our plants that we get a semi-reliable DSL connection.
Yeah.
You know, a lot of the GEs and the SAPs of the world build these local data centers, and they probably own 25% of fiber in the world, and so their stuff is highly connected.
Yeah.
But the rest of us don't live in that world, and so it becomes a little nerve-wracking that this is going to work for us.
Yeah.
All these connectivity pipes.
Yes, so you would be surprised that GE has a number of plants that have no network connectivity at the plant level, or very spotty connectivity at the plant level. A lot of GE manufacturing plants are in very remote areas, and it becomes very difficult for connectivity. So what we've done is we've partnered up with some telecommunication vendors. And so in Europe, we've partnered with Vodafone. In the US, we've partnered with Verizon to be able to provide cellular connectivity at the plant environment, to be able to pull that information. And so we've also worked with our own plants and with customers to be able to work through, you think about the network, what are the bandwidth requirements that we have? Is that something where it's going to tax the operational plant network such that you need to put in a separate network just for these capabilities? And so we've worked with a number of customers. In some cases, we're leveraging Verizon to do that, to provide that capability. In other cases, they're running it through the existing network. But to answer your question, we are working through a lot of those details, both internally with our own plants, as well as with some customers. Any other questions?
To make all this just work, you need to standardize your data and data packets. And, is this who's driving, like ISA95, SADA? And what's driving the data standard?
Yeah, so when we think about that common data model that I mentioned that we're moving to, that's a way for us to internally represent the data. But what you're describing is like the ISA95 equipment model hierarchy, for example, that we can take the format, that common data model that we have, because we have a common way of representing all of the data, we can then transform it into that hierarchy. And so we use FE50, which is a flow model, ISA95, which is the equipment hierarchy. But if there's another model, we can use that model as well. It's just a case of transforming the data from that model that we've defined to represent the information out to a specific hierarchy.
So it's an internal kind of
Yeah,
proprietary, you're going to translate what comes into
that's right.
the figure model.
That's right. Any other questions? Okay, thank you.
All right, lunch is near. So we're almost ready here for a break. So hopefully you've seen, I mean, we've gone from George, who talked about investing really into the future, the government investing into manufacturing and also into infrastructure to try and improve it, trying to make a lot of the things more real for all of us and some of the situations that the reality that we're in. And then Keith went on to talk about really what GE is doing internally to help themselves as a large manufacturing conglomerate, but also how that software is going to translate down to you. Hopefully, I think Marcella's almost ready here. She will be presenting kind of an overview of the products that you all are familiar with and are using today, and kind of where that's headed, and the results of why they're headed down this path based on some of the stuff that Keith was talking about. So we're kind of bringing it down a little more real to all of you and what's the impact here. And I think Marcella said she could adjust a little bit of time, so we're not, she already is banning her between you and lunch and the break. Please be kind to her, but welcome Marcella Marquez. She's a channel manager. She introduced herself earlier today. She's a channel manager for GE Intelligent Platforms. She works directly with INS. So those of you, our customers, will see or can see or at least hear from her at some point or another. And she's been that since January this year. Prior to that, she was an MES consultant also for GE, supporting the manufacturing account team and process manufacturing processes, et cetera. She mentioned earlier too, she's a former Mountain Systems employee, which is the predecessor of Plant Applications. And she's also a native of Costa Rica, so she's done some work there as well. So please welcome Marcella Marquez.
So hello, welcome everybody. I'll try to keep this pretty quick so we can go on. So what I wanted to do today is talk a little bit about where we're at today. We heard of where we're going from Keith, where we want the industrial internet to take us. When we talk about industrial internet, we talk about three factors, and we heard it already. Really machines, so how do we get the data from the machines that we have already on the plant floor? How do we transform that data into analytics, into actionable information? And how do we provide that information to the right people at the right time? So those are the three factors that we take into account when we're talking about the industrial internet. For GE, and Keith mentioned this, it is something that's real. We are monitoring a large amount of equipment, a large amount of data comes out of that equipment. And we have a big group of people talking about that and how do we, not just talking about it, analyzing that data and trying to figure out what that data means. What's the action that needs to take place based on that data? And what brings us to what we can do industrial internet, why we're talking about this, is now we can connect to the equipment. We have a lower cost of sensors. We have a lot of data coming out of those sensors. We have wireless communication, so we don't have to draw network cables through the different plants. And Keith mentioned it that we can even do cellular networking to gather that data into a cloud or into a local cloud or a private cloud. It doesn't have to be a big cloud environment. It can be something smaller. And we have the tools to do the real-time intelligence. As we collect that data, we can transform that and transform it into something of information, not just data points that are changing from 0 to 1, and the cloud computing that we talked about. So when we talk about on the plant floor, we're talking controls. The control system is going to enable us a system that we can respond to, something that we can be proactive, not just reactive, and something that we can be continuously improving. So from the information that we gather, we can continue improving and modifying it to give us more information again. So these are 4 factors that we have looked at when we talk about real-time information. And these are what we see around this chart are things that customers, real customers of GE have found. For example, just from gathering the information and preventing through workflows mistakes, a company reduced 40% of their waste just by reducing the loss of batches. We saw an increase in 70% productivity from the operators as they get information in the right information to the right people at the right time. We also saw a 33% increase in capacity. From the intelligent alarmings or warnings, 100% increase in energy efficiency. So that's double the amount of energy that they would consume, or sorry, optimize. Then we saw an increase in the detection of problems and also an improvement of our troubleshooting. And this part is when you have the mobile capabilities, you don't have to be tied to your machine or your HMI on the plant floor. You can remotely troubleshoot the issues and give information or support to the people on the plant floor. That allows you to reduce the amount of time that you're going to need to troubleshoot this. And that's what customers have seen. So we've seen the user experience, not just the user interface, where we have the tools, we provide the dashboards, but more the user experience and the customer experience. That's what we're working on and what we are seeing the real value on. So the user interface are the different tools that you're going to see from a product. And then the user experience is what you're going to be doing with that product. How are you going to be using that for your process and for your operations? When we talk about preventing mistakes from happening, we're talking about tools that are going to give you electronic work instructions or the information that you need for an operator to be the best operator. So all operators to be the best operators, giving them the information that they need. So, for example, we have invested in our product. Our SOA workflow product has now better installation capabilities, better user interfaces that you can create forms on the web. So thin clients that can be accessible in any platform. This is one of the customers and what they mentioned from using our products, and I'll let you read what it says. So this is some of the experience that they found when having, what I mentioned, the right information at the right time. Then give intelligent warnings. It's not just having an alarm trigger when something happens. And you know, when an alarm triggers, it's already too late. You have a machine stopping, your production is not running, you need a part that you maybe not have on your inventory of parts, and then you have to react quickly and get something rushed. So instead of having that, we can be monitoring different signals from different areas in your process and putting the knowledge to those signals. And but with the experience that you have from your process and different algorithms that are in place, you can tell instead of the end of the start when the alarm happens. Previous to that, you can see there's an early warning to tell you, okay, this process, if it continues this way, you're going to have a failure. So you can react to that so the failure doesn't happen, or prepare and have the parts and the time and the people in place so you can react faster to that failure that's going to happen and replace the part that you need from your process. So this is what we mean about early detection. And this we do through different programs right now, different products. We have the Seasons product that Keith mentioned, but we also have through our mobile platform the way of creating the analytics and the troubleshooting internally and creating these algorithms so you will get the alerts before time. And you can create those individually. So for example, this is a case from a customer that they get an early notification that this air handler unit has a problem or before it fails. And the cause for these signal or alert was that the mixed air and discharge air control loops would have different segments. So by fixing this, and they managed to reduce the amount of chilled water that they were needing, and that, putting that into numbers, it was between 2,000 and 3,000 kilowatts hour per year for one unit. And we can do the math here for 10 per 100 units. And this is a real case study, something that customer did. So quickly identifying the problems, and we saw Keith talk about the new HMI, the next generation HMI. So in 1990, this is what we saw. This was an HMI that we could see. This is what we see today. We have a lot of information or data into one screen. And that causes the operator to be a little bit lost into all of that information. Where is the issue? Where is the alarm coming? What is the real thing happening here? So what we want to do is to make it simple, to make it intuitive to the operator. Just they see the screen and they know what's going to happen, what's the process, where the issue is going to come, where the alarm is going to come. And make it seamless so they can be reacting and moving through the process and information in an easier fashion. So this is where we see something like this. This is the next generation HMI, and this is something that it's in the roadmap to be released by Q3 of this year, Q3, Q4 of this year. So something that's real. And tomorrow, Prasad Pai is going to be here talking to us a little bit more in detail about this platform. So we have a completely different look and feel, as you see from our traditional HMI. And we have signals, we have alarms, we have areas we can enter nodes, and everything is into the same screen. We have another example here where we have the same as we have before, the main HMI graphic, but we also have trends, we have different types of data representation that will allow the operator to intuitively understand what's going to happen with the process before it happens. And then provide on-demand support. And this is where all this mobile technology and the different platforms come in place. So we have created, with the release of our Prophecy mobile platform that was released, I think it was a month or 2 months ago, so it's now a product, it's available. One thing that we have deployed is the Prophecy mobile for phone factor, for the phone environment, so it can be an iPhone, it can be, so it's for
Android.
Android, thank you. Yeah, it's not this one. So I have it on I have it on my phone if somebody wants to see it. So there's some changes that were made, so it worked on the phone. So you have the different KPIs, and you can trend them. They have different ways of seeing the data. And then we also created scorecards where the different industries can connect to their ERP system and create their indicators and show them on the same mobile environment. So you don't have to have different platforms. You can create those KPIs inside. And also, another thing that was created with this release is we incorporated troubleshooter into the KPI analytics and also different reporting. So this is different type of analytical views, and we have like an executive summary, a fleet analysis where you can see all the different equipment that you have on the plant floor and look at what are your alarms and what are your what's the performance of your different assets. And this, if you see, this is on a tablet environment. This is another type of report that's out of the box now with this system. So this is one of the from Cornell University that I was mentioning to you, that just from having the ability to go into their mobile system, a tablet or a phone, they could see exactly what the operator was seeing and troubleshoot remotely or support them in their decision making on how to fix a problem they have. So that's one of the benefits we saw. So with this mobile technology, we got Company of the Year award from Frost & Sullivan. So this already, Keith talked about this, on how to connect the equipment, how to get inside and optimize. And a little bit about the historian. So some of the things that we see right now from Historian 6.0 that was recently released, we have now an HTML5 for administrator. We also have the critics core in it, so where that is real into our GIP products. It's not something that it's far away, we're already doing it. We have expressions that we can be incorporating into the collector. So as the data comes in, you can be modifying that through calculations. And instead, if you think of a historian as sits traditionally, we had 2 tags that we were, if we wanted to do an addition, we had 2 tags and we were consuming 2. What we're doing right now with the expressions at the collector is that you can have 1, do the math, and you keep on having 1. You don't have an additional one that has a result. So that's something that we can do at the collector level, and also with PHA, the historian analysis, we can incorporate those calculations inside PHA as well. So that's another benefit that we see. So we heard Keith talk about going from the different products that we have right now to one solution, the Prophecy Enterprise Manufacturing. And I'm not gonna go into detail on this one. So what are we doing right now? We're going from data everywhere to actionable knowledge at any time and anywhere. So we're investing in getting faster troubleshooting to your solutions, increased energy and chemical savings, improved uptime, and also on the regulatory compliance on the quality side of our products, and increased process visibility. That was, I promised it was gonna be quick, so. Questions?
On your mobile apps, where's the engine that's driving the function from what we're seeing in practice on the mobile phone?
That's on the application server, still has that,
Yours or mine?
yours,
Okay.
yours, yes. So still, you can have it in your, in a cloud environment, in your server, you can have it, you can own that. Any other question? Okay, thank you very much.
Right, she gets an A+ for going through that quickly, that was awesome. So, we're right up around 12 noon, but just we have a couple minutes, I just want to give you a quick highlight of this afternoon because we've got a couple of our customers who've been very gracious to take the time to present some of the things that they're doing in their operations that are leveraging all the things here that we've talked about, and some in a pretty advanced manner. So please make sure we're here, we're gonna get started right at 1:30, so we'll keep you on time because we've got a relatively packed afternoon, but we wanna make sure that we get out of here at 3 o'clock. We've got the Tech Expo, those guys are still there. We have, some specialized extra time there that you can use for yourself or to go ask questions. I wanted to point out that George will be with us tonight at the event, but Keith has to dash, so he will be around for lunch. He'll be around here till about 2 o'clock. So if you do have questions and if you are too shy to ask in the open forum, if you want to grab him during lunchtime, I think he's able and available to do that. So, and George as well, and like I said, George will be also joining us this evening at the event. We're going to make sure that this afternoon we try and keep as much on track as possible because we have buses leaving. We want to make those of you that are joining us, hopefully you all are, joining us to the rooftop event. If you haven't done that ever in your life, it's one of those bucket list things you have to check off, and they're fun and certainly will provide an opportunity. If you're interested in baseball, you can see the game as well tonight, but more importantly, I think it gives us all an opportunity